Hey, what's up everyone? Welcome to the stream. So, to be honest, I'm really tired, so I don't think I'm gonna last very long. But I still want to go on a little bit because I haven't streamed for about a week. So we'll just see how far I get. I just wanted to share some stuff that I was looking at since last time. I thought it was kind of cool. I was looking at sorry, yeah, I was looking at OpenGL stuff, and I was looking at specifically GL debug stuff. And I had no idea, like I'm totally late to the party, but I had no idea that that there was a better way to know when you misuse or when an error occurs when you use like an OpenGL API. You know, like when you make calls to GL API and you pass in the wrong parameters or something goes wrong. In the old days, I'd have to like use GL get error all over the place, like after every call. And I've had old code bases where I did that kind of thing, and in fact, I even started doing that kind of thing in my own code. I think I still have it. Let's see. Yeah. See, like I added in my GL util here some stuff that's related to GL get error. So I have this like reset GL error, which basically loops through GL get error until it returns no longer any errors. I have a check GL error that calls it and sees if it's not equal to no error, then it prints something, gets the error string and prints it. I create a little scoped check GL errors thing. Hey Will25, how's it going? So I did all this, and of course it sucks to use this, right? I started like using it, and then I got into the issues of, if I scope a GL error and then I call another function that ends up calling more GL calls, and I scope those, what happens if, the inner one causes an error or the outer one causes one, but I didn't check the value yet. Hey Lisp Gamer. And so I was like, oh, this really sucks. And so I was like, maybe there's something to this. And I started looking into the GL error stuff, and I found out, and this is like probably super old there, but like I found out about the KHR debug core ARB extension. And basically, it's this callback mechanism where if you create what they call a debug context for OpenGL, you can basically get a callback for all kinds of errors that you might get. So this is like, there's like different classes of errors. You can see it here. For example, for source API. So you make a call to the OpenGL API, and if it causes an error, then you can get called back for that. So these are all like sources that you can enable or disable. You also have stuff related to the Windows System API, for stuff that comes from the compiler for the shading language. There's this debug source third party, which I don't really know what that is. You can generate your own errors if you like. Do I know where what breaks? I'm just talking about how I didn't even know about this this whole GL debug system. Yeah, you see, you wrap every call with GL check, but there's like absolutely no reason to do that, which is really cool. This is sort of what I'm sharing here. I used to do that. That's actually what I started doing, and then I was like, this sucks, I hate having to wrap every call and all that. So yeah, it's really cool. So check this out, right? So you have all these sources that you can configure. You have severity. Do you get the file line number? Yeah, so I'll address that as well, but yes, you can. Will25 asks if I'm Italian. I am of Italian descent. I mean, I'm born in Canada, but my family's from Italy. So yeah, so basically you have all this stuff here. You can configure which severity you want. You can send, like I said, user messages, and then you have this GL debug message callback function that you can use to set up the callback you want. So it seems pretty straightforward, but actually it's not super straightforward. I had to do a couple things to get this to work, and I haven't actually cleaned up the code, but I'll show you what it looks like right now. It's kind of cool. So there was a couple things I had to do. One of the first things I had to do was, and this is, you know, in particular when you're dealing with SDL, you have to make sure that before you create the GL context, that you tell it that you want a debug context. So I didn't have this, and so for a while I wasn't getting any callbacks, and I couldn't figure it out. And then I looked into it, and then I finally found some info about this. So basically, the way you do this in OpenGL is I have this function create GL context, where you set up stuff like your major and minor version of OpenGL you want to support. This here tells it you want the core profile, and then here I just check if I want to enable GL debugging. Then I create a debug context so that we can use GL debug message callback. And so you do that by first getting the current context flags, and you basically enable this SDL GL context debug flag, and then you go ahead and set it. And then when you create your window, it's going to create a debug context. Sorry, when you create the GL context, not window. So that basically makes it a debug context, which says that, you know, we want to get information from that. So after that, like later on when you're initializing your OpenGL stuff, sorry, zoomed in. Okay. So here, what I do is, so I'm using, what's it called, glue. So I check to see if the GL debug message callback function is available. It should be available, but just in case, I check that it is available. And then here's a bit of the answer to what you were saying, Lisp Gamer. What you were asking me about was, sorry, I just wanted to. Okay, I thought my stream cut out there. Is it really choppy, or is it all good? Because it's looking potentially choppy here. I don't know. Yeah, I'm also using GLM, but for basically getting, you know, access to all the extensions and functions, I use glue. Whoops. It is choppy. Is it always choppy right now? Okay, hold on a second. Okay, I think it should be better now, but we'll see. We'll see how it goes. So let's see. I'm in the same stack as you, SDL glue GLM. Cool. Yeah, that's really cool. So yeah, so then you could totally do the same thing here. And I mean, I haven't pushed this yet, but I'll be pushing it tonight. So basically, you come here. So what I do is, you know, I showed on that page that you can configure which sources and severity. I think it's sources. Sorry, sources and also the type of error that you're interested in. So there's different ones, like, you know, do you want to know about just errors that typically come from the API? Are you interested in some deprecated behavior? So if you want to know about deprecation stuff that you're using, undefined behavior, portability stuff, performance stuff. There's command stream annotation. So this is more like getting information. There's also group pushing, which is something I also experimented with, and I have in my changes since last time, so I can show that afterwards. Push group, pop group. I don't know why they put foo here. Anyway, and other, whatever that means. So the way it works is you have these functions called GL debug message control, and it's a bit of a strange kind of typical of OpenGL. They're like a catch-all function that does way too many things with too many parameters. But basically, what you do is, or what I do, is I have, like, I go and enable everything by default. So I say GL debug message control, and then here you say for source, I don't care. For type, I don't care. And don't care basically means I want everything. Severity, don't care, which means everything. So count here, whatever, it's 0, and I have no IDs. This is the number of IDs you want to pass in, because you can also control, yeah, so like when you send your own debug messages, you can give them unique IDs, and then you can kind of turn on and off which IDs you would like to receive. So that gives you quite a bit of control if you want to generate your own messages. I mean, I'm not really sure why you'd want to do that, but there you go. So whatever, I'm not using that. And then here you say, I want to enable. So I want to enable all sources, all types, and all severities. And then after that, what I do is I choose to disable certain things. So I have an array here of sources that I would like to disable. So I have the list of all of them. And right now I'm disabling the ones that come from the shader compiler. And the reason for that is, I mean, I'm not sure if I should do this, but basically I'm doing it because when I compile, I already have my own error checking right after I compile. So I'm already getting this information at the point I compile, like at the point where I actually invoke the shader compiler. And so having both meant I was getting like duplicate information, because it would emit information about if I had errors or whatever, and then I would get back a callback saying the exact same thing. So in my case, I'm not interested in getting this callback. For types, I'm using push and pop group, and I get callbacks for each of those, which I don't really want. So I disable those. And then the way to do that is you actually have to call GL debug message control once per thing you're disabling, right, or enabling. So I have a loop here for the disable sources, in which case it's only one. And here you say, I want to disable this source, and there's the GL false is what means I want to disable it here. So I'm disabling sources here, and after that I'm disabling specific types here. So I pass in the type parameter, and again false. So this is how you configure everything. Sorry. Yeah, so once you have that going, then, oh yeah, and I think I forgot to mention at the top here. So yeah, I started talking about this. So you have this option called GL debug output synchronous. So this basically says, as soon as an error occurs, I want you to synchronously call my callback. So this is pretty much like on the GL call, if there's an error, immediately call me back. And that allows us to get the call stack. So you were asking Lisp Gamer about the call stack. This is how you get it. If you don't set it to synchronous, then you'll get called back asynchronously. So at some point, I don't know when the driver decides, and then you'll get no context whatsoever. So, I mean, for me, I think it's super useful to get the stack. So I would totally go for synchronous. I assume that there's some overhead per call, but then again, if you're opting into debug information, you probably want that overhead. Maybe if you wanted to kind of keep this enabled in a release build without extra overhead, maybe you'd not make it synchronous. I don't know. And then there's the setting up of the callback. How much hoop jumping to get the stack? You're actually asking me? Like, I'll show you what it looks like. It's not that big a deal. Because it's synchronous and it happens as soon as the GL call is made, you pretty much have the call stack. Sometimes the call stack, like, it does that thing where because you've gone to the driver and come back, you don't get a complete or correct call stack. But if you just kind of step out enough times, eventually your call stack will be correct. So I'll show an example of that. So this is the callback here. It's the function pointer expects you to use this API entry calling convention, and yeah, you just have to follow the format. So you're going to get called back with the source, the type, the severity, the size here, I think, of the length of the message or something, although it's null terminated. And you can also pass in a user param. So that's for if you invoke it yourself, you can pass in some data you want. So right now I'm just like basically logging an error. That's pretty much it. So nothing big. But let's say like I enable this breakpoint here. And I actually have an error. I think I just wrote some random characters in one of my shaders. You see? Yeah, it was in the darkened texture one. So I wrote something here. Although this was actually for me to test more the errors coming back from the shader, so that's not going to make a difference. Let's see. Hey Raptor. So yeah, you're saying I can use stack walk 64 if you're trying to walk the stack procedurally, for example, to save it to a file. Yes. Yeah, for sure. So yeah, I'm just trying to think like how I can force. Oh yeah, so actually I fixed a real problem that I had because this helped me detect one. I haven't pushed it yet, but I can kind of bring it back and you'll see what it was. So it was here in GL util. It was when I do the load shaders and I compile shaders. I actually had gotten this code from somewhere else, so that code was clearly incorrect. What the hell? Hold on a second. Oh, my windows are all over the place. Honestly, you like your GL check macros? Yeah, well, I mean, you know, teach their own, right? But I kind of like not having to put checks everywhere, you know? Like I can just make straight up calls. Yeah, I know, but then you gotta like wrap every single OpenGL call, right? You know, either use a macro or you literally wrap everything, right? So this year I don't have to think about it at all. And what's cool is if I use a third-party library, and there's a bit more than that, right? So you can see here that you can get back errors that you would not get from your GL get error. You're gonna get stuff like performance warnings or you know, deprecation warnings, things like that come from the driver itself. Not that I've received one yet or gotten one, but apparently that's the kind of thing you could expect from certain drivers. So I kind of like that idea. So it's more powerful than GL get error. So yeah, so for example here, I was calling this check status here which I call for compile shader. I'm calling this function that basically what does it do again? It does like get shader. It's getting some information here for checking the status. And the thing is that, as it turns out, you're not really supposed to do that for a link program. And I learned that because I got an error for this. So if you want to see what that looks like, let's say I bring this back here. Oh yeah, Raptor, you didn't know? Yeah, every call. Okay, so this, I think, let's see here, check, oh, I see I had renamed it. So let's say I just call this check compile status for now. And here as well. Okay, let's just see if this actually builds. Yeah. Everyone with their pseudonyms, nobody knows who they are. Okay, so this builds. So if I run this, I should get a call in my GL debug message callback. Okay, so here we go. And so just to see, like, the message that I'm getting here is GL get shader IV parameter pname has invalid enum. So, you know, here's the call stack. You can see that we're getting called back from ATI OGL XXDLL. So that's the my ATI driver. And then it says frames below may be incorrect or missing. And sure enough, this is not really where I'm at. Like, it's showing here this make current, but that's really not what's happening here. So what I did was I just stepped out with Shift F11 a couple times, and boom, or not boom. Let's see here. Did I step out one too many times? This is not working. I think what's happening is that I'm hitting another call every time. So yeah, unfortunately, in this case, I don't know why I'm not getting it, because clearly I got it last time. That's how I pinpointed where the problem was. Strange. Let me try and disable the breakpoint. Yeah, no, that's the thing. The stack frame isn't correct. That's the thing. You know how, like, that can happen depending on, like, the way depending on the way the driver, how it's optimized. Like, it's probably optimized so that it doesn't save the stack frames. What is it again? Like, store the stack frame in some register. So, like, see, it says when that happens, it says here frames below may be incorrect and or missing. And I don't know why this time around I'm not able to just kind of step out of it. And usually I do this. I Shift F11 just enough times to get back into a function stack where it's able to resolve the call stack. But right now I'm just unable to do it for some reason. Well, yeah, I guess I haven't convinced you just now, right? I wonder why. I wonder if let me try and debug just to see if it makes a difference. Yeah, one thing for sure is that with variadic templates, or, you know, even just with C++ 11 and forwarding references, you can oh, what's this? Oh, yeah. That's also part of my change there. Yeah, with forwarding references, with perfect forwarding, you can easily write wrappers that do things. I guess with variadic templates, I would do it for this. But still, I do really like using OpenGL straight up without having wrappers everywhere. So let's see. Do I have something better now? So now we're in debug. I guess not. No, it didn't crash. You know what I'm talking about, right? When I say like sometimes this error here, when you see frames below may be incorrect, it's because the debugger is unable to figure out what the call stack should be. And that's because of certain optimizations. Like there's an optimization you can enable that you should try to avoid if you want to be able to see call stacks. Let's see if I can find it. This one, omit frame pointers, right? So some people do this because it can actually make your code run a little faster, or it can sometimes it's done on purpose by drivers to obfuscate what's going on. Yeah, there's nothing. I mean, there are things on the stack. You can see this, like these offsets into the driver. Yeah, it's using register passing. Yeah. But see, like if you're not using, if you don't enable that option for the stack frame, see omit frame pointers. From what I've understood, this is the kind of thing that could basically make it difficult, if not impossible, for the debugger to figure out what the call stack should look like. You know, so be able to say where this call comes from. So, and I think that might be happening here. I think this is what this message usually comes down to. And normally, I mean, and I was able to do this, but I don't know why. Now it's just not working for me. So, you know, not to show that I'm not completely crazy, if I put a breakpoint in here, so I think this is for the shader, so it should be okay. Let's see here. Yeah, so this one should work. This one as well. And I think that's the third one that should fail. You see, I just hit F10. So this time it actually was able to keep the call stack. That's kind of sad. So you see how, like, if I have a breakpoint at the point where it messes up, and then I got called here, now my debugger is showing. In fact, it's not even completely right. You see, it's showing that I'm in link program, which is true, but I'm actually a bit deeper than that. I'm in check compile status, and I'm on this line here. I wonder if now, if I shift F11, if it would work. Not yet. It's a bit disappointing. It's disappointing that it's not working exactly the same way. And I do think, you know, if I have to take a guess, it has to do with my ATI GL driver. And I say that because actually when I wrote this code, I tested this on my laptop, which uses like an Intel, you know, onboard GPU, and it has its own driver, and I was able to get better call stacks. And I expected it to work well here, but unfortunately it doesn't work super well. So, I mean, it gives you some information, but not perhaps everything you wish to know, especially if the call stack is not reliable. I don't know. You know what? I feel like taking a quick look to see if there's any information about that. Yeah, so Raptor is saying I can look for debug DLLs. I think my graphics card is so old. It's like ATI does totally have like a symbol server, and you can get debug versions of your driver, but I think for mine it's just too old. At least that's what I think. if I look at, where would I see it again? The debug bit is set in the context, right? That's how I even get the callback in the first place. So this is my crappy graphics card driver. So I have this, you know, HD 5670. Pretty sure I'm not going to be able to find a debug driver for this. I think here I'm not going to find it. AMD. So there's a symbol server. Please note that we currently just host the binaries. In our case, these are a set of DLLs, not the PDBs which is what you would need to resolve function names. There are currently no plans to release the PDBs. So here it's saying that when opening a 64-bit crash dump, although in my case it's a 32-bit crash dump, you'll not necessarily get a sensible call stack. This is because 64-bit crash dumps need to have all the binaries available to them in order to resolve the call stack properly. Typical crash dumps don't come from your machine, but someone else's, be it from the quality. This means you might not have the correct version of all the binaries. So yeah, so there's a symbol server. I have tried to use the symbol server. I think I've even have the configuration still, but it's not. It doesn't find it for my graphics card. It's just too old. See here, download AMD.com. Or here, Durbin. I think I tried a few different things. Here they show to put the Durbin 2018. And then it says if you want to go before 2018, so I added both. I tried both, and it was unable to find them. I mean, we could try it right now. Like if I have HD gaming starts here, yeah, right? I think I actually have to restart for it to load the symbols. Where's my... So yeah, in fact, you can even see that it loads all these ATI drivers here. ATI GKTXX and ATI GKTXX. It's always the same one, isn't it? Yeah, loaded, unloaded, loaded, unloaded, loaded. So yeah, it keeps reloading this one. And like I looked for this specifically in the set of PDBs on their, not PDB, sorry, on their symbol server, and I wasn't able to find it. See, now it's trying to load symbols for everything. It takes a super long time because it looks for every single thing it wants to look for on that symbol server, which really sucks. But actually, I don't need to do it that way. Hold on. If I go to modules here, ATI. So here we are. So symbol file. Let's try here. Load symbols. And there, see that saying I can't find the PDB. Sorry, my font size is too small. Yeah, I guess I didn't put the size up for all my windows because I think that would be a bit difficult for me to work. I have it large for the main source code, but I don't think I'm gonna go and start changing the fonts for all of this, you know? I'm sorry. PDB, DBG, so yeah, cannot find or open a PDB file. If I grab all of this, yeah, so you see like basically, see it wants PDBs for all this, but they're saying, what are they saying here? They're saying that even without the PDBs, I might be able to still get resolved call stacks. I don't quite understand that. All the binaries. Oh, I see. Okay. So this is kind of interesting. This may actually be a reason for me to switch to 64-bit. So okay. So what they're saying here is this is not the case that the use case I'm looking at here. This is the use case of somebody else got a crash and they sent you a crash dump. And so that, you know, you got a crash dump from somebody else. You don't have exactly the DLLs that they have on their system, and so using this allows you to download the right DLLs for that match what was, you know, used on that other person's machine. In my case, I have the DLLs, right? So there's just no point looking for them again. The DLLs don't come with PDBs, so you don't get names or anything. But what they're claiming is that just with the DLLs alone, if you have the correct ones, at least in 64-bit, it should be able to resolve the call stack. So I am running in 32-bit, and I wonder if that's really what I'm suffering from. No, I'm not running a 32-bit OS. I don't even know if Windows 10 is available in 32-bit. Is it? Maybe. Oh, I guess it is. Huh. Okay. But no, I'm in 64-bit. So you know what? It could be interesting actually to try and do that. I'll put that on my to-do. Like let's get this checked in, and we'll look at. I don't know. I think I have both. I think I have 64-bit drivers as well. I think that's how it has to work, right? Yeah, I am on 64-bit Windows 10. But I think if you're running a 32-bit application, it's going to need 32-bit drivers for things to work. Yeah, I compiled 32-bit. Yeah. my massive water thing here. It's a swell. Okay. Yeah, so I think I'm gonna focus on doing that thing afterwards. Yeah, the reason why I'm in 32-bit is literally only because it was like, what was it again? When I started the project, it was kind of like the default, you know, when you create a project with CMake, by default it selects Win32, and I could easily, you know, add a 64-bit, but, well, I guess easily. I could do it manually, but I'd have to go and there's a couple of things that I think when you run CMake, you have to tell it, oh, I would like to generate a 64-bit project, which is not difficult or anything. But to do that, I would also need to download 64-bit versions of all my dependencies. Again, not difficult. So it's something we could try, because I am interested to see if we get better call stacks in 64-bit. I know the calling convention is a lot cleaner in 64-bit than it is in 32. So it's possible that, you know, with the more standardized calling conventions and rules for argument passing and all that, that the debugger can figure out the call stack more easily. Edit and continue. Oh, really? In 64-bit? So Lisp Gamer, you're stuffing stuff into pointers. Okay, let me decide how I'm gonna do this. A part of me wants to hide all this behind my GL util, which is probably what I'm gonna do. All right, Lisp Gamer, thanks for hanging out. All right, I prefer to do this because I don't like having you know, like 7 or 8 arguments to a function. So I'm just going to make a little struct to hold all these parameters. And I'm going to say that basically I'm going to call you back with a function that will returns void and accepts this structure by ref. Okay, so now let's implement this. I think I need to include functional. Alright, so create definition in glutil.cpp. Perfect. Okay, so what I'm going to do is I'm going to store this in a global. Let's do this. What the hell? My keyboard is in a weird state. It's doing like page up, page down. Why is it doing that? Okay, it's back. Sometimes that the kind of thing happens. My keyboard goes a little wonky and I'll just do this. Okay, so message callback. So if we actually have a callback, and I'll say that's a way to enable it. So you could disable it by calling it with null pointer. So I'll just use that. That'll be my API. Now, if I come back to GL render, let me just copy all this code here. Okay, now what I'm going to do is this. So I'm going to hide the real callback that we will register, and its job will just be to forward to the message callback here. Now I'm going to make sure that it's valid, because we should not have a callback registered otherwise. And then we say severity length, so we'll just initialize our struct using aggregate initialization. Like that. And for now, I'm not going to expose any of this disabling of sources and types. I'm just going to go, like, since there's no need really. If ever I have a need to play around with this and expose it, I'll just expand my API. But for now, this should be fine. Now, if we did not get a callback, we would need to disable. So actually, how do you disable? I don't know if I can pass a null here. It says it has to be an address of a callback function. Otherwise, it's probably just disabling the GL debug output, perhaps? I don't know. So GL debug output or synchronous. If enabled, debug messages are produced by a debug context. When disabled, the debug message log is silenced. Note that in a non-debug context, very few, if any, messages might be produced, even when GL debug output is enabled. If enabled, debug messages are produced synchronously by debug context. If disabled, debug messages may be produced asynchronously. In particular, they may be delayed relative to the execution of GL commands, and the debug callback message callback function may be called from a thread other than that in which the commands are executed. So I guess I'd have to disable both. Maybe I should be enabling both, just to be clear. Just saw this coming out of SDL2. GL create renderer. Okay, so if you use create renderer, it actually does its own thing. GL handle debug message. Oh, that's cool. I'm not actually using this, but that's pretty neat. The CSDL is doing the same kind of thing. Okay. So what we'll do is we'll say GL enable GL debug output. No, not here. Maybe what I'll do is I'll make sure before I set the global pointer, if I have it, yeah, I'll say like this. If you passed in a callback, and we can do it, well, I guess it doesn't really matter. I'm gonna set it first because one advantage to this is that it'll be set to null or to whatever. So, although, yeah, no, that's good. That's good. Yeah, that's fine. All right, so if we go back to, let me see if this compiles. Okay, compiles, fine. So now we can change this code to be a bit cleaner than what we have. See, I was already planning to do this. So set debug message callback. ASMR palm rubs, yeah. My hands are always cold. So now I need, yeah, I just need basically a callback function that matches my new way of doing it. So we'll do it like this, void that accepts a message info. And in fact, I was gonna say I'm gonna use I could for sure use a lambda. However, when I did that last time, one of the problems with using a lambda is that if it's too small, it gets inlined and I'm unable to debug it, which kind of sucks. And there's no easy way to like tell it not to inline a lambda. Which is why I actually have a function here. Oh, and this should be probably GL util. And it does not like something in here. Let's see what it is. Okay, so let's see if this works. All right, so here we set the debug message callback. So I'm going to create a temporary function. Which actually I should be moving here. So we move that in here. We are valid. Have this, so we enable all this stuff. We actually register the real callback, which is up here, and then we do our thing, and we're good to go. Okay, and so later on I get this call again. The stack is not completely right. It's close, but it's not completely right. But we see we got this call, and then we make sure we have a message callback. We invoke it. And here we are. Perfect. And that should spit out something like this. OpenGL debug message. GL get shader v parameter. So there we go. Canadian tax season, right? Okay, so that should work. See, we get a bunch of errors, all pretty much related to the same thing. Now, if we bring it back, okay, so it's here. So basically the link program should not be checking the compile status. And now when we run, we should not get any errors. And sure enough, we don't. And see if we let's take off this breakpoint. So if we try to put a breakpoint in here and we run and release, I think this one gets optimized. Let me just take a look. I think it gets inlined. I'm not sure. I know it gets inlined if it's a lambda expression. Oh no, we're good. So we're in good shape here. Man, I am so cold. It's freezing in my basement. Okay. So I'm pretty happy with that. So let's get that into Git. Thanks, HSRU. It's true that there are only 33 released games. However, there are quite a lot of homebrew games for the Vectrex. I don't have an exhaustive list, but I do have a list that if I could... Here, give me a second. I'm just going to pull that up. Be right back. All right. Sorry, I have to like sometimes hide my screen because I have like multiple desktops, and when you open things like code, it sometimes opens the wrong desktop. So, all right, let's see Vectrex stuff here. Yeah, so just to give you a little bit of an idea of, oh, actually that was the wrong one. New window. So you did not know what Raptor, that about the fact that there was a lot of homebrew. So here, I made this list here. In fact, you know, it's probably just easier to see it directly on GitHub rather than me showing it in a text editor. So if we go to Vectrexy here, my compat list. So like this is a section on the commercially released ROMs here. Yeah, and it's like you said, it's about 33. It includes these light pen ones and these 3D imager ones. But here there are commercial unreleased ROMs. So these are ROMs that were made by the developers that just did not get released. So they're like prototypes and stuff. And then you have this set of homebrew here. And you can see that it's quite large. Now, to be fair, a lot of this is like sound stuff. It's like here. Now, I actually split them out. So that's right, I did split them out. So this is all just audio demos. But the rest here, these are actually, should be games and demos. So I'll further split this out into actual games versus demos. But yeah, you can see like quite a bit of old school. Quite a bit of homebrew. So that's pretty cool. And some of the homebrew is amazing, like way better than the commercially released games. Yeah, only 33 games. And they were all made by GCE, the company that made the Vectrex. So yeah. Man, I'm literally freezing. Let me just check something. I have access to my thermostat on my phone. Oh, it's not even that cold. Maybe it's because I'm tired. Anyway, okay. So let's see here. Oh yeah, I needed to bring back this assert. Again, I'm on the wrong desktop here. Alright, so I wonder if I should do separate check-in for this, just kind of keep this clean. I think that's what I'm going to do. I'm going to stage all this. So I'm going to say here, add support for GL debug message. Take care, Raptor. And I'm just going to commit this now. Fix, how do I say this? Fix invalid check for compile status on shader linking. So yeah, actually I mentioned this earlier and I kind of wanted to share this as well. One of the changes that I committed was this GL render add debug groups for each shader pass in ImGUI. So if you've watched my previous streams, you will have seen that me using RenderDoc, which is an awesome tool. But I've always had some trouble with RenderDoc with identifying like which draw calls corresponded to what in my code. And I did discover a couple things which were really cool. Like one of the features in RenderDoc that I think is really awesome is that you can enable, when you do a capture, you can say collect call stacks. This is a really cool feature because it basically, I can actually demo it here. It allows you to see the call stacks for every single API call that it captures. So you just set this on, you do a launch here, and I guess I should also explain the thing about the groups. But let's say I grab a capture here. So actually, before I get into that, the other thing that I did, because you're going to see this right now, is to ease debugging, you can use another thing which is in OpenGL called GL push debug group and GL pop debug group. And this is really just for like saying, you know, I'm going to create some kind of named group here, and then all like the GL API calls I make are going to be considered part of this group. And it's really for debugging applications. So RenderDoc is one of those that taps into this, but you know, any debugging application you want to write, something that analyzes the debug info, can will get the information about these groups. And it's a whole like hierarchical thing. So you can have groups, push groups, and all that. So what I did is I just basically added, you know, these APIs here. So push debug group with a name and pop debug group, and I have a scoped debug group struct just to make things easier. And then you can see, like, for example, here in SDL engine, when we're about to render the ImGUI stuff, I call a function, and in there I have a scoped debug group that's just called ImGUI, and then I call render. And for all my render passes, actually, I think it's going to be easier to see it in the diff view. Let me get that open. Yeah, so I used to do this thing where I would set a name for each shader, but that wasn't all that useful to me. So I replaced it with this. When I'm about to say run the draw vectors pass, I create in the draw function a group for all the calls I'm going to make here called draw vectors pass. Same thing for darken texture pass and glow pass, and combine vectors and glow here, and scale texture pass, and finally render to screen pass. So these are all now grouped. So when you go into a capture here on the left side, we can see that for the frame I captured, here are all those groups that I mentioned. And RenderDoc is really cool because it actually shows you the groups and makes everything hierarchical. So here you have that draw vectors pass, and if you expand it, you can see that there's the GL draw arrays that I did. Darken texture pass as well. There's another draw vectors pass and another darken texture pass, a glow pass which does 2 draws. Combine vector and glow, scale, these are all just single. Here you can see there's a clear, render to screen, and then there's the mGUI stuff here. So I just find that really cool. And then as for the call stack support, when you click on one of these, there's this call stack window at the bottom here. And it says symbols not loaded, tools resolve symbols, so you do exactly that. And it goes and reads the PDB files. And then you get this full call stack. So you can see here that I was in STL engine run, GL render scene, in my anonymous namespace darken texture pass draw, calling draw full screen quad. And it tells you the line number as well. So this is extremely cool for debugging, to get exactly where, I have now the passes that help me a lot, but on top of that, I have for each call exactly the line number that it corresponds to. So I think that's pretty neat. So I kind of wanted to share that. Okay, so I think the next thing I'd like to try is the 64-bit thing, because I'm really curious about the call stack thing, just to see if we get a better call stack in our debug function. But before I do that, I just need to go to the washroom, so I'll be right back. All right. Okay, so let's see here. So yeah, let's see if we can, how difficult it is to get this to be a 64-bit build. So what I'm gonna do is I'm gonna close this. Good job, HSRU. So what we're going to do here is, let me close this. And the reason why I'm closing it is because we're going to regenerate we're going to regen so we're going to run CMake to regen the solution and project and all that. I just want to take a look here in my CMake lists. Okay, so these are all the third parties, and I think in my README, yeah, so I have these steps here where I specify specifically x86, and I think all I would need to do is change these for x64. So let's see. Let's replace that. Let's see if we can at least get these packages in 64-bit first. CD data code active VC package. All right, let's try this. So it resizes my window. All right, so it's starting to download everything. So it's going to do this. It's also going to have to compile them. So this can take just a little bit longer. That's all right. And while it's doing that, we can actually generate our project in 64-bit. So let me see how you do that again. So I use the generator here. All right, it's here. So basically I use CMake, and I know there's like I need to specify the generator. So let's get into that. I'm gonna make a build folder called build x64, let's say. And let me just remember how CMake works with the generator. So you specify this and you specify the architecture. The arch is Win64 ARM, so we want Win64. So I'm gonna add that into my stuff here. So CMake -G, let's say like this, Win64, followed by the toolchain file. So this of course won't work because I don't have the, I won't be able to do this until the other step is finished, right? Okay, let's see how far are we. Doing SDL2. Yeah, this could take some time. Although I think SDL2 is probably the biggest one. Glue, GLM, ImGUI, libpng, zlib, stb. Those should be pretty fast. Actually, SDB is not even in my list. Additional packages will be installed to complete the operation. Oh, so SDB will be. Okay. I see that it's also building the debug versions, which is nice, but I wonder if it could tell it to only build the release versions. See, because if I try to generate it now, but I don't specify the toolmake chain file, I think it's going to fail because it just won't find the packages, the dependent packages. Yeah, I know. Got really mad one day and I just cleaved it right in the middle. Okay, this is going a bit faster now because the other packages are smaller to build, as I suspected. SDL2 net. So HSRU, what brought you to the channel? If you don't mind my asking. It's true that there are a lot of changes I made actually since the last stream. I was trying to improve performance, which is why I ended up looking at debugging things and looking at grouping in RenderDoc. So I did a bunch of stuff here. Yeah, I did make my draw full screen quad faster by sending vertices and UVs to one buffer, because I was actually creating two separate buffers for that, which was completely unnecessary. This is where I had added shader names for debugging, but then I removed them and replaced them with the groups. Avoid clearing texture. So this one here is, I'm not super happy about it. I removed some clears, but actually I think it's not a good idea. There are many streamers who actually publish stuff. One of them went offline an hour or so ago, so I began looking. 10 channels later, I found yours. Oh man, thanks for hanging out. I really appreciate it. So okay, where are we? We've got SDL2, SDL2 net. Now it's doing glue. Okay, so we're getting there. After glue, there's still GLM, libpng, and imgui. So 3 more. So yeah, like I was saying, yeah, I'm not super happy with this like no clear thing, because like, okay, let's say we reopen our project here. I'm gonna have to fix this because and honestly, I don't think I'm saving all that much with this, but it did show up. You know, the clears, they do show up, and I think it's because I have fairly large buffers. But it's not worth it. So here's the issue, right? This is the issue. On the side here. And I think that clear that I need to bring back to fix that is... Which one would it actually be? I think it's the last one. Here. The render to screen pass. I think we do need to clear the target. This is the one place where the whole window is basically represented by the back buffer. This definitely would not need the bit there. I don't really even have a depth buffer, but it doesn't really hurt to try and clear one. Okay, so let's see if that fixes the issue. Yeah, there we go. So HSRU, this is your first time here, so you really haven't seen the Vectrex in action, right? So I guess while we wait for this to build, I can show you a couple of cool games if you're interested. Okay, so I have a bunch of games here. So like, okay, so let me see, what's a good game to show you? There are the classic ones. Like there are some, so some of the classic ones that I grew up playing myself that I really liked is Scramble. This is one of them. So this is actually apparently, it's originally an arcade game, and they got the license to make it for the Vectrex. Oh, hold on, I gotta turn off the noise. So that's the undefined ignore. All right, here we go. Let me fast forward through this. So this is a game where you basically control this ship that can fire forward and can launch up to 2 missiles at a time. And yet at the bottom of the screen you have this like gas gauge, this fuel line. This says fuel level there. And so basically you're just trying to get through the level, and it's pretty cool. There's kind of like 4 different areas. You have to learn how to control your ship well. So one thing that's interesting to notice about the Vectrex is that actually the Vectrex is a black and white display, but this thing you're seeing that's colored, this is actually an overlay. And on the real Vectrex, you would basically put these overlays directly over your screen. So each game came with its own overlay. So like if I actually have an overlay alpha here, so you can see like if you don't have the overlay on, it would look something like this. And you can see like there's a, this kind of like effect of, kind of like a blinking effect and a trail effect that's going on, a bit of a glow. All of this is basically to kind of try and simulate what the CRT display would behave like. And I'm doing all that in shaders. Keeping my eye out on the build. Looks like a VC package is done. Hey Synachron, how's it going? So we're almost done the 4 areas, and then basically it starts all over again, if I can actually make it through. And the idea, of course, like most arcade games with time, is just to get the highest score. So I don't even think it gets any harder. That's one thing about this game. I think it just remains the same level of difficulty. See, this is the hard part right here. We had skins for our consoles. So to be fair, this is my day. However, I was 3 years old when the Vectrex came out. But my uncle, who was about 12 years older, he got me one. Hey, I made it. Phew. I don't know if I've ever actually made it. You have to get this thing here, which is super hard to do. Anyway. Last try. See? Anyway, whatever. Okay, so we've got all our 64-bit packages. So let's see now if we can generate our project. Let's get back to generating the 64-bit project. So here we are. You're noticing the sizes of the files? So these are actually the size of the ROMs here. 8K. They're usually smaller than 8K. There's a few, yeah, that are larger. I mean, up to 32K. That's pretty much as big as they get. Because that's really the space that was allowed there. You had about half the... you have a 16-bit memory bus, and you can get half the size for your ROM. So the very first 32K bytes is for the games. And there are some games that could be larger using bank switching. But yeah. So you saw a couple of 252 bytes in there? Let me see. There's some, well, yeah. There's even a 90 byte one here. But these are like music ones. And a couple of test ones. Yeah, I know. So, okay. Let's see if this works. We're gonna want to do this. I'm gonna need to give it the correct path though. So I've been thinking about making a 64-bit build for a while. One thing I wonder is, will it be faster or slower? It's not a straightforward answer. Okay, so it actually generated everything. That's really cool. So yeah, it's not totally straightforward, like whether you'll get a faster performance or slower performance. From what I understand, if you're doing a lot of mem copies, like a lot of moving memory around, 64-bit can be very advantageous because you get access to 64-bit moves of data, whereas on the other hand, like all your pointers are actually 64 bits, so they're 8 bytes, and if you have a lot of pointer stuff going on, then that's the kind of thing that can actually make your program slower because of the fact that these pointers will take more room in cache, and so you'll end up with the likelihood of stuff remaining in cache is less likely due to things like alignment of data as well. So it really depends on your program. It's not like a straightforward 64-bit is faster or 64-bit is always slower. It really depends on your program, and I'm not really sure what I expect. I have some data movement, I have pointers, but I really don't know. Are we actually min-maxing? So you'd be surprised about performance when you're doing emulation, right? Like, you know, depending on what you're doing with the shaders and just emulate. And I have a debugger and there's a bunch of stuff that it's doing in the background. I mean, I'm not really having an issue hitting my 60 FPS here, but on older hardware or on specifically on my laptop where I don't have a proper GPU, yeah, it can be challenging. Oh, thanks for the follow, Jono Xlive. Okay, so let's see here. Let's set this as the startup project. Let's make a debug release build with debug info, and let's go for gold. Let's see if this actually works. I'm going to try and build this. Make it run on mobile, exactly. Or maybe somebody suggested I try and get it running in the browser using WebGL or like ASM.js or something. Oh, so I have some 64-bit stuff that it's complaining about. Just gonna let it finish building and see what we get. Okay, not too bad. Okay, so I've got some stuff that is not 64-bit friendly. So let me take a look at this. I'm using a size T position here, and is that on here it wants a long, I see. Do I have a I don't think I have it. I had this like cute little safe cast thing that I had written at one point, but I don't think I have it anymore. Not in this project anyway. Oh no, I do have it. Checked static cast. Yeah, there it is. Cast truncates values. This is really cute. Basically, you say I want to do a static cast of a value from a type U to a type T. And what it does is, so you specify the T and you don't specify the U. And what it does internally is that at runtime, it's going to make sure that the casted value is still equal to your value. So basically meaning that, you know, no truncation occurs. So that's the kind of thing I'm going to do here. So I'm going to say check static cast to a long of the position. So that's for stream 91. So let's see if this builds. I don't really have, yeah, streams.cbp. Okay, so that builds. Let's keep building and tackle the rest. So basically what I'm saying here is that I know you're passing a size T, and size T can be larger than what Seek actually, where did it go? What it actually supports. But it's okay. I'm going to make sure that the value pass in does fit into a long. And that only happens in debug builds, actually. It won't happen in release builds. So it's a cute little trick. Okay, so initializing conversion from size T to unsigned int. So this is unfortunately in the PNG library, which, man, I need to get rid of this. So I think it's this unsigned int, could it be? This returns a PNG size t. So why am I using int here? I think this code was actually copied, so. Alright, that builds. So conversion from size t to GL size I. Ah, yes, okay. Probably gonna have a couple of places to do this. Oh, here's a GL int that I want. No worries, man. Conversion from size t to int again. So what are we looking at here? What wants an int? It's numlines. And this is string to integral, which returns size t. So I guess I could just make this size t. Nice, it builds. So let's see if it runs. Great. Oh, that was pretty easy. You know, I get the distinct impression that it's actually running faster. So we're getting about 130, average 125 FPS here. So I still have the other builds. We can just run it right away and see if I'm right. So 125 FPS for the 64-bit. Otherwise, we get... Let's see here. Maybe I'm wrong. Oh no, this looks about the same. No, it's even right now it's saying 129, so really not faster. If anything, it's slower. See here, I'm averaging 130. Come back here. I'm getting about exactly the same frame rate, 130. So definitely we're not doing enough on the CPU for it to make much of a difference. Alright, that's pretty cool. So now, the moment of truth, let's see what happens in our debug callback function and see if we can actually get a stack there. So GL render, and I need to force something invalid again. Actually, one way we can get that easily. You know what? Let's do the same exact thing we did before, because this way we're comparing apples to apples. So we'll just bring back that change I had here in link program. Okay, check this out. We just got a callback, which is exactly the same error as before, but this time when we look at the call stack, we have a valid call stack. And we see here, this is the call that's failing us. So this is exactly what I was hoping to get before, but I was not getting this in 32-bit. But in 64-bit, we totally get this. And it is, I believe, what I was saying. It's due to the fact that in 64-bit, the calling convention is standardized. I think when they defined the 64-bit calling convention, they made it so that, you know, the return address is always in some specific register. Forget what it is, but it means that now, even without symbols or anything, just basically as long as you have the DLLs there, it's able to figure out. Like here we know ATI06, this 6 must be for the 64-bit, I guess. Anyway, these DLLs, it's able to figure out like where it's coming from and then come back to the original call. So that's pretty sweet. And if you ask me, if that's, you know, if that's all we get from 64-bit, it's totally worth it. It's interesting here, it says inline frame. Inline frame. What does that mean? Does this actually mean that this is not a real frame and that this is an inline function call? Inline frame. I don't think I'm gonna find that. Yeah, I'm not sure. But yeah, I think that's what we're seeing here. We're actually seeing the debugger is able to somehow figure out, oh, this is an inline function call. So this is func class. Okay, so it's basically the it's inlining the stood function invocation with our lamb. No, sorry, that's it. Stood function. Yeah, that's it. That's really cool that it actually shows this information. Wow. Yeah, this is way better than in 32-bit. Like in x86. I should have done this a long time ago. So yeah, I think I'm totally going to stay in 64-bit, and I'm going to commit these changes here. Okay, so this will be separate. GL render. Don't always. Okay, revert. Revert the no clearing of the back buffer to fix artifacts of scrolling, to fix moving ImGUI objects. From moving ImGUI objects. So revert the no clearing of the back buffer to fix uncleared artifacts from moving ImGUI objects. Alright, I understand what that means. And I just need to revert. Yeah, I need to revert the thing I just did in GL util. Use, okay, so I'll say fix update readme. Fix instructions. Good enough. Alright guys, I am going to push this and I'm going to call it a night because I am really quite tired and I think we did some good work. We also saw some pretty cool stuff tonight, so I think this is good. So if everything works out, I should be streaming again next Monday night. So thanks again guys and see you next time.